May 13th, 2017. Equifax's security team gets an alert. An unknown actor is pulling data through a web application vulnerability. The patch for that exact vulnerability had been available from Apache for 78 days. Nobody applied it. By the time anyone understood what was happening, 147 million social security numbers, birth dates, and home addresses were already gone. Here's the part that should bother every developer in that story. The threat existed on a diagram that nobody drew. A threat model on that single data flow, the one between the public-facing web app and the consumer credit database, would have put a red box on exactly that component. The framework for doing that has a name. It's 6 letters. Nobody wrote them down. There are 6 threat modeling frameworks that security analysts actually use. By the end of this video, you'll know what each one does, when to reach for it, and why 88% of teams still start with the oldest one. No security background required. Let's map them. Draw a blank canvas here. 6 boxes, we're filling them one at a time. First box. Stride. Stride is the one that started everything. Lauren Kohnfelder and Prerit Garg built it at Microsoft in 1999. Adam Shostak formalized it into Microsoft's security development lifecycle by 2002, and it's been the industry's default entry point ever since. The 2024 to 2025 State of Threat Modeling Report, which surveyed 60-plus organizations, found Stride at 88% adoption. Nothing else is close. The name is a mnemonic. 6 threat categories: spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. You draw a data flow diagram of your system, every process, every data store, every data flow, every external entity, and then you walk each element against all 6 letters. Does this component allow someone to pretend to be someone else? Spoofing. Can data be changed in transit? Tampering. Can a user deny an action they took? Repudiation. Can private data leak out? Information disclosure. Can the service be knocked offline? Denial of service. Can a low-privilege user gain admin access? Elevation of privilege. Draw a crude DFD here, one box labeled Web App, an arrow pointing to a box labeled Database. Circle each Stride letter next to that arrow. That arrow is where Equifax's red box should have been. Adam Shostak once noted that Stride's staying power comes from its mnemonic simplicity. A developer can remember 6 letters and apply them without a tool, without a workshop, without a consultant. That's why it's still number 1 after 25 years. Second box. Dread. Dread is Stride's companion. Microsoft built it as a scoring tool to answer the question, Stride can't. After you found all these threats, which one do you fix first? 5 dimensions: damage, reproducibility, exploitability, affected users, discoverability. Score each one from 1 to 10. Add them up. The highest number goes to the top of the fix list. Draw a 5-row scoring table here. Put a big red retired stamp over it. Because here's where it gets complicated. Microsoft stopped using Dread internally around 2008 to 2010. The problem wasn't the concept, it was human behavior. Teams started gaming the numbers. They'd score their own threats low to make the risk look manageable. The numeric precision was false. A 6.4 out of 10 sounds objective. It isn't. Dread is still widely taught, and you'll see it in certification courses and textbooks, but it's the only framework on this map that its own creator retired. Know what it is, know why it exists, know why Microsoft walked away from it. Third box, OCTAVE. OCTAVE stands for Operationally Critical Threat, Asset, and Vulnerability Evaluation. Carnegie Mellon University's SEI CERT division published the original version in 1999, the same year as Stride. They refined it into Octave S for smaller organizations in 2003, then Octave Allegro in 2007, which added a worksheet-based approach for asset-centric risk assessment. Octave is the odd one out in this group. Every other framework on this map starts with your system, your code, your components. Octave starts with your business. What are your most critical assets? What would hurt the organization most if compromised? Then it works outward to infrastructure vulnerabilities and ends with a prioritized security strategy. Draw an org chart here. Business assets at the top, arrows flowing down to tech vulnerabilities, with a CMU building in the corner. 3 phases. Phase 1. Build asset-based threat profiles. Phase 2. Identify infrastructure vulnerabilities. Phase 3. Develop the security strategy. The whole process requires a small, cross-functional team, not just engineers. That's intentional. OCTAVE is the framework you reach for when the people who understand the risk aren't the same people who understand the tech. 4th box. PASTA. PASTA stands for Process for Attack Simulation and Threat Analysis. Tony Uceda-Vélez and Marco Marana introduced it in 2012. Their reference book, Risk-Centric Threat Modeling, came out from Wiley in 2015. PASTA is the attacker's framework. It asks one question at every stage. What would a real attacker do here? 7 stages. Define objectives. Define technical scope. Application decomposition. Threat analysis. Vulnerability and weakness analysis. Attack modeling, risk and impact analysis. Draw 7 numbered boxes in a chain here. Color boxes 1 and 2 differently from boxes 4 through 7. That color difference matters. Stages 1 and 2 are run by business stakeholders. Stages 4 through 7 are run by security engineers. PASTA is the only framework in this group with a formal cross-functional handoff built into its process. Business leadership defines what matters. Engineers figure out how an attacker gets to it. The 2024 Naik et al. Comparative paper, published at C3AI London and indexed in Springer, scored all 6 frameworks across multiple dimensions. PASTA ranked highest on attacker simulation depth. If you're doing penetration testing prep or red team planning, PASTA is the framework that speaks your language. 5th box. VAST. VAST stands for Visual, Agile, and Simple Threat. Threat Modeler introduced it around 2018, and it's built for one specific problem. What do you do when your team ships code every 2 weeks and can't afford a 3-day threat modeling workshop? VAST runs in sprints. It uses 2 separate models in parallel, one for application threats, one for operational and infrastructure threats. Those 2 swim lanes integrate directly into CI/CD pipelines, which means threat modeling happens alongside development instead of as a gate before launch. Draw a sprint board here. 2 parallel swim lanes, one labeled APP model, one labeled OPS model. The Naik et al. Comparison scored VAST highest on agile compatibility. If you're in a DevOps environment and Stride feels too slow, VAST is what the comparison paper points to. 6th box. LINDDUN. LINDDUN is the outlier. Kim Wuitz, Ricardo Scandariato, and Wouter Jussen built it at KU Leuven in Belgium in 2014. Every other framework on this map is a security framework. LINDDUN is a privacy framework. 7 categories: linkability, identifiability, non-repudiation, detectability, disclosure of information, unawareness, non-compliance. Where Stride asks, can an attacker steal this data? LINDDUN asks, does this system violate the privacy of the people whose data it holds? Draw an eye with a line through it here and label the 7 LINDDUN categories around it. NIST references LINDDUN in its privacy framework as a recognized privacy threat modeling approach. In 2020, the team released LINDDUN Go, a lightweight card-based version that fits directly into GDPR compliance workflows. If you're building anything that touches EU user data, and 45% of cybersecurity teams now integrate threat modeling into security operations, according to ISC2, LINDDUN is the framework that regulators recognize. Now here's what the Naik et al. Paper actually concludes, and it's the most useful thing in the whole comparison. No single framework wins. Stride leads on ease of use and tool support. PASTA leads on attacker simulation depth. LINDDUN leads on privacy focus. OCTAVE leads on organizational risk. VAST leads on agile compatibility. DREAD is the only one officially retired by its creator. The 2024 to 2025 State of Threat Modeling Report confirms this in practice. Most teams don't pick one and stop. They blend Stride with 3 or more other methods depending on what they're building and who's asking. So the map looks like this. Stride finds threats by component. 6 letters works on any DFD. DREAD scores them 1 to 10, 5 dimensions, but Microsoft retired it for a reason. OCTAVE starts with business risk and works down to tech. PASTA simulates the attacker across 7 stages with a built-in business-to-engineering handoff. VAST runs in agile sprints with 2 parallel models. LINDDUN maps privacy threats for GDPR and every regulation that follows it. Equifax had a security team. They had tools. The threat modeling tools market hit USD 1.28 billion in 2025. The tools exist. What Equifax didn't have was a structured process for asking what can go wrong on this specific data flow. Stride on one diagram, 78 days earlier, would have put a red box on CVE 2017-5638's exact entry point. 147 million records, one undrawn diagram, 6 frameworks that could have caught it. Pick one and start drawing.